Hey folks, is this the performance meeting? I think I joined the performance meeting. Josh, do you know are we
Yeah,
using that room?
same room.
Okay.
But I think that the stuff ritual stuff is over now, so I was just hanging out until the performance meeting started.
Okay. Well, yeah, we can start the performance meeting. Lots of new faces here, so feel free to stick around, folks, if you want to. Otherwise, well, I don't know that we have a ton today. We'll see. Um, so let's see. The usual suspects are not here. I don't see Adam or Igor. But today I thought that we would go over a couple of different things. So first one is that the blog article about QEMU performance got posted. So that is here if folks are interested. The gist of it is that we had a user that was really interested in seeing how fast librd could work with QEMU They wanted to know on a fast cluster just what the fastest numbers we had internally were. And we didn't have anything recent. We had some really old stuff, but nothing really recent. So I went through and kind of made a guide for looking at QEMU performance and kind of some different tuning parameters that help. Um, and kind of the gist of it is that we could do 123,000 16K random reads from a single VM and about 65-ish thousand 16K random write IOPS when everything was said and done. If you enable encryption, Messenger version 2 encryption, those numbers do go down. On the read side specifically, I think we ended up somewhere around 80,000 or 87,000 or something. So it was like maybe a 30% performance hit. And kind of interestingly, all of it seems to be in the messenger threads on the client side. In both cases, they were running at 100%, just doing work, getting data to and from the client. And when you are doing encryption, that's happening in the messenger threads as well. So maybe something like 15% of the time or maybe it was like 15 to 20% of the time in each messenger thread was being spent in OpenSSL decrypt functions. And that was using AES-NI and like fully, utilizing the hardware capability of these CPUs. Um, Turns out that when we are looking at message frames and segments specifically, we actually iterate over uh, buffer entries and buffer lists. I don't know how many per message we were doing. After talking to Ilya, it sounds like we definitely are doing a small header, like decrypting a small header individually, and then potentially some overflow from that header along with the payload and whatever's in the payload. So that's probably slowing us down, specifically regarding decryption. Not sure if there's anything we can do about it. Ilya seemed to think that we're kind of limited in terms of the way that we construct and deconstruct messages over the wire and do over the wire encryption and decryption. But yeah, we'll see. Um, so there's that. I don't know if anyone has any questions about it. Happy to answer if not, or if so. All right, well then, moving on. Igor, I see that you're here now. I wanted to mention or talk about some of the work that Adam was doing with snapshots. He doesn't look like he's here, but we've been doing some further testing on it, and it looks like the new version is maybe a little bit slower than it was previously. Um, I can get you the data in just a second here. So that is here. So for everyone else that's here that hasn't been coming to the performance meetings, we're trying to figure out a performance issue that we're seeing with RBD Mirror. And a couple of different people, Paul and Gabby, have been looking at this quite a bit. And we kind of determined that it ultimately is coming from snapshots on the OSD side. When you take multiple snapshots and are doing snap trimming work, we see that OSD usage tends to shoot up, and it gets worse over time the more you do. When we looked at this OSD side, what we were seeing is that because the more you take snapshots of things and do snap trimming, get rid of old snapshots, but the more you do this while doing kind of random writes to the underlying data, you see that objects get more and more fragmented. They have more shared blobs and they have more extents. And initially, we were thinking that it was primarily the fragmentation of extents that were causing problems. And there's still maybe some evidence that that's making things a little worse. But we ended up kind of going two routes. Adam started looking at whether or not shared blobs were primarily responsible, while I kind of went down the route of looking at fragmentation and extents. And so this first tab in this spreadsheet is Adam's kind of looking at the results of some of Adam's testing and work. And he tried to basically get rid of shared blobs kind of in their entirety. He still has one that's used for tracking purposes, but we don't have lots of shared blobs per object. Instead, there's just one now. And the initial versions of his his branch looked really, really good. That's kind of the yellow and green, the yellow and maybe, I don't know, red, I think it is, lines there. But it wasn't working, it wasn't passing all tests. And when we tried it with RBD Mirror, it just kind of all broke. So he worked on fixing some of those problems, but unfortunately now we're seeing that the performance isn't nearly as good as it looked initially. It's actually a higher kind of base level CPU utilization than even just master or main is now. But the peaks are lower. So it's a mixed bag, but it's not looking nearly as nice as like the red and yellow lines that you see there, where we went actually almost down to nothing, no overhead for doing snap trimming and snapshot creation. So that was what Adam did. What I ended up doing, I took kind of a different approach and looked at just trying to basically defragment objects when they become too fragmented when we take snapshots. So the upside here is that, especially on hard drives, it makes the overhead of taking snapshots much lower because there are less extents to iterate over and less shared blobs in general. Once you've defragmented the object. The downside is that defragmentation process means that you are basically doing rewriting the object out in a single new extent every time that you end up with an object that's too fragmented. So there's a fair amount of additional write amplification on the device. They're big writes, they're nice big writes for hard drives, but it's extra work that needs to be done. So the result of that work is in the second tab here. You can kind of see that it helps, maybe not as much as Adam's initial work did, but it might actually be a little bit less than the fixed version of Adam's PR. We'll see. I'm hoping that Adam can maybe figure out what was going on, and we might be able to make his work look a little better. But for now, that's just kind of where we're at. The downside with my work, if you look at the second tab, whip BS clone defrag, the second graph down, there's a disk usage graph, and that kind of shows the oscillation where space amplification is increasing due to the fact that we're doing these extra writes and creations, and now snapshots maybe have data that's not associated with that new object. So we're taking a little bit more space. It's no longer just the extra space of the snapshot. Sometimes there is a little bit of duplicated data between the snapshot and the current version that you have. But since the snapshot's immutable anyway, it's more space usage, but they shouldn't get like out of sync with each other or anything, unless they're supposed to. Maybe the bigger issue is that if you scroll down to the device write throughput graph, you can kind of see that we've got this write throughput that's hovering around 100 megabytes per second. That's entirely due to work being done during snap trimming to basically defragment objects. It's a fair amount of extra write overhead. But on hard drives, you kind of want to defragment objects anyway when they get super, super fragmented. So, we can tweak some of the parameters to lower that, but that will also mean that we'll be closer to the original CPU usage. So anyway, this is what Adam and I have been working on. Igor, I kind of wanted to just point out that the work right now with getting rid of shared blobs maybe isn't quite as good as we originally thought it was. I'm not hearing you very well, Igor. I don't know if it's on my end or on your end. Just barely.
Can't hear you very well either.
It seemed to be mostly a volume issue. I could hear you, but just barely.
Is it better now?
Still quiet, but better. That sounded fairly loud. Give it a try and see.
Okay, anyway, I don't have any. But, well, honestly, I don't have much to say.
Okay. Yeah, I could kind of make it out this time. So, good enough. Igor, one of the things that we are kind of talking about more though is maybe some of the big changes we've been discussing in the past couple of weeks regarding BlueStar's write path, and I wanted to kind of maybe bring up again that the idea of maybe some kind of BlueStar 2 or BlueStar branch where we could start really making some of these big changes. Do you think is that still the way you'd prefer to go if we tried doing some of these things like making kind of big changes with shared blobs or deferred writes, these kinds of things?
Yeah, maybe. On the other hand, maybe it's worth starting with determining some goals we want to achieve with new BlueStar version 2. So in this respect, I would rather prefer to start with simple implementation and then expand it.
One of the things that's come up again has been kind of how to deal with hierarchical storage inside the OSD, inside BlueStore, I guess specifically, and maybe even beyond, hard drives. If you had, um, you know, typical hard drives, if you have even slower devices behind that, and I've been thinking a lot about deferred writes and kind of how to deal with this hierarchy of devices now that can exist in the market. And then that's, for me personally, that's kind of one of the directions I'd really like to see us explore more, is how to, whether or not we can make the write path simpler, but then beyond that, how can we better utilize all of these different kinds of devices that are available. I think to some degree it ties in a little bit with your write ahead log work as well, right? Like, that's we've seen benefits already, even just with your prototype, and fairly significant ones. I think that's one of the. Yeah, go ahead.
Well, we had that conversation with Adam as well, and it looks like we might want some design for general purpose logging stuff, which might support PG log, RocksDB write ahead log, maybe these deferred writes logs, and something else. So it looks like there are multiple use cases for this login pattern.
Yeah. Speaking of which, actually, the RGW team right now is working on trying to prototype using objects for bucket indexes rather than OMAP. And they're having, I think, some troubles with trying to do small appends to objects and achieving high performance with it. So that's when you talk about logging, that's that's one of the first things that comes to mind for me.
Yeah, but unfortunately, in this respect, it looks like my write ahead log is already a bit legacy. So we might want to have a new design for Paul. Originally, it was not supposed to support multiple use cases like that. So, well, anyway, this worth some discussing and thinking.
Yeah.
But yeah,
Yeah.
again, it looks like generally we might want to have some login engine inside BlueStore or BlueStore version 2 with multiple use cases and yeah, so, which should be being able to work fast on fast devices as fast as possible.
Yeah. Adam or Casey, you guys kind of know what the current status of the FIFO work is right now? I know like a week ago, I think it was, you guys were having a lot of trouble with small writes and even like aggregating small writes into bigger appends. It sounded like it wasn't going very well. Is that still the case? Do you know?
Hey, Mark. Can you refresh my memory? That doesn't sound. I know that we're debugging some FIFO stuff for multi-site, but I don't think it's related to performance or appends.
Off here, but I thought Matt was saying that you guys were trying.
Mark had noticed that.
Oh,
so the way Mark has his cluster set up, he has the OMAP part of the OMAP part of the OSD offloaded onto ZRAM, and there is in OSDs, as I understand it, this sort of fast memory, slow memory offload, or fast storage, slow storage offload that can happen. And what we were wondering about is if there was a way to make the basically these FIFO objects, which are about 4 megabyte blocks with a bunch of, say, 100 megabyte writes in them, to have those writes specifically be offloaded onto the fast memory, so that we don't lose performance relative to OMAP.
Sure. So we have this concept with BlueFS where extents can BlueFS extents specifically can know what device they're on, and like that's kind of, I think the primary use case for that is just with RocksDB SST files, so that they can exist on either device potentially. But we don't really have anything like that, as far as I know, on the just like the block device side. Like it's only in BlueFS itself. Igor, does that sound right to you? That's my recollection of how all this works.
Yeah, that's right. So user data can go to main device only, and while BlueFS supports multiple devices for its data. But that's for RocksDB only, or you should use BlueFS directly somehow. But we do not expose any APIs.
Yeah. So I suppose that would be the easiest route to get there if we wanted to have something like that, would be to go through BlueFS. But I don't know what the ramifications would be of actually, exposing that and trying to do it.
Right, so I'm afraid BlueFS is not very good in working at scale. But it has never been used like that, and I have some concerns if we start using it in bulky manner and of multiple users and
Yeah.
files on it.
Igor, how crazy do you think it would be to make it so that we can, not with BlueFS, but just in general, know which extents live on which device?
Well, technically that's doable, but I'm afraid that's just a small piece of the picture.
Yeah. My hope would be kind of that maybe we could, if we did that, then we could kind of migrate away from the current deferred write path and always have new writes land on the fast device, unless they're really big. If you have a big extent, maybe you decide to put it on the slow device, or not. If like in this case that the RGW guys are talking about, if maybe they just always want to write to end up on the fast device. But I guess my thought was that, especially for small extents, we always have them land on the fast device. Then eventually, as that fills up, we say, okay, this object is really fragmented with a lot of extents. We're just going to now defragment it out to the slow device and do a big extent right on the slow device. And hopefully that way we can keep the hard drive from becoming heavily fragmented, and we can do just straight non-deferred writes to the fast device, which hopefully will be fairly performant.
Yeah, but it looks like this requires some abstraction layer on top of that. So, and that might be this general logging engine. So, yeah, the idea. The idea is that deferred writes to be staged to this logging device, a login engine, and then processed in a background manner and
Yeah, exactly.
back to main device. Similarly, like it works for deferred writes and RocksDB at the moment, but maybe more effectively due to absence of this RocksDB stuff.
Yeah, and I'm not thinking anything quite as extravagant as like a full LSM, right? Like that seems like it's way too much. but more just
Right, especially for keeping user data in this database, you know.
yeah,
If we keep just metadata, then it's okay. But when we talk about deferred rights, we keep user data there as well.
yeah. I'm probably thinking more something along the lines of the way some of these different block cache layers work, but hopefully maybe we can do it a little bit better if we do it inside BlueStore itself. If we did that, we could also then think about compression happening once you write out to the slow device, right? Like you could do fast uncompressed extent writes to the fast storage, so that compression doesn't get in the way. But then once you take an object and want to do like a full big write to the slow device, then you could compress that, and then if you do overwrites on it, you don't recompress. You just do your little writes to the fast device and have those extra extents. And eventually, when you want to get rid of them, you just then rewrite the object and recompress it. At least that's kind of how I'm envisioning this.
Yeah, but generally, all this stuff requires some architecture.
Yeah, right? I know it's big. It's a lot. But and maybe it's not even worth doing, right? Like maybe with CStore, we just focus on that. I don't know. There are use cases now that are kind of asking about this kind of thing, though. So and more I've been thinking about it. So yeah, Igor, maybe think about what you think. If you're pretty much our the I think the most knowledgeable expert on BlueStore these days. So um, if you have concerns, I definitely want to hear them.
Concerns in what respect?
Just regarding if it's worth it, if this is a good idea, or if we should just try to keep BlueStore kind of roughly the way it is now.
Well, actually, this greatly depends on the status of CStore Crimson project, which
Yeah.
I am actually unaware. So, maybe I'm wrong, but it looks like we are still far from production for Crimson, and we might want some eventual development of BlueStore. Then it worth efforts indeed. But if my assumption is wrong and we are close to Crimson, it will resolve all these issues, which is another question.
No, your assumption is accurate. I think they're going to have a development preview or whatever in the release of Crimson where you can turn it on and run RBD against it, but it's going to be missing features like it still can't do PG splits and merges.
Yeah.
And they're hoping to support RBD on Crimson for real, at least with adventurous users in the S release. So it's going to be a while before anyone thinks BlueStore doesn't matter for performance.
Yeah, Greg, there's been kind of a desire for it to be ready like this year, and I think that it's probably not been realistic, frankly.
Not to mention that already from development point of view, it's already from user one might be completely different with a couple of years gap between them.
In terms of BlueStore, I mean, there are things that I think are easier to do than others. I don't know how bad it would be. Well, let's say, okay, in terms of kind of migrating away from the deferred IO path, at least right now, we don't have to like rip the deferred path out to experiment with other stuff, right? Like we can just leave it there until we get to the point where maybe we have something that works better. So that's kind of nice, right? Like Igor, I don't think we'd have any trouble just trying out some of these ideas with like always doing a non-deferred write to a fast device and then migrating over to the slow device. We can just leave the current deferred write path. I don't think they'd interfere with each other, right?
Yeah, they shouldn't. But again, I think first of all we should set the priorities and decide what we really need for this BlueStore version 2. Let's name it this way. I mean, do we really think that deferred writes are a very important topic for upgrade at the moment?
So
any use cases which suffer from that and they require immediate attention or things like that?
there's definitely something, I forget the details. Adam can talk about more. He's working on it right now, very aggressively to try to fix an issue that came up. But I think it was just a corner case. That's why he's changing some of the logic to make it a little bit more straightforward regarding when we actually do deferred rights and when not. In general, though, I mean, like, I don't know how you feel about it, Igor, but whenever I look at like do write small and kind of the conditions that we have there about when to do deferred rights and when not, it's really unclear how we make those decisions.
Well, I concur with you, but apparently that's not a great reason to make significant changes at the moment. So I would start with use cases which requires such modifications. So anything we are suffering at the moment. So for me, for instance, RocksDB performance is one of the major issues we have so far. Not default rights,
So, okay, let me comment on that then. One use case that has come up from customers is that they believe that BlueStore, for whatever reason, they believe that the deferred write path should work like file store's journal. They think that they've got this much write ahead log with RocksDB. If they make that really big, they should be able to write really quickly to the NVMe drive with like small I/O and then have it flushed in big chunks out to the hard drive. That's the belief, not necessarily reality, right? But that's what they think is supposed to happen, and then they get confused when it doesn't.
But well, maybe it's not that ideal, but on the other hand, it should provide some improvements for spinner drives, for direct drives, to spinning drives. So okay, maybe I need more details on this case to make any decision, but so far I can say that I saw tons of customers suffering from deferred rights. So we have one bug in Quincy and maybe Pacific, which is still to be resolved, and but it doesn't require any redesign.
You're just talking about the one that where if you have it set to like 64K or whatever, you have to
Yeah, right.
Yeah.
That's true.
Yeah, that was a fairly minor bug, really. Okay, well, yeah, I guess.
So again, when speaking about this logging engine or maybe you write ahead log, this is an attempt uh, to get some burden of RocksDB. Uh, since it looks like we still unable to generally kill this issue with RocksDB performance degradation, it worth significant efforts. But default writes.
One thing to think about in relation to it too is fragmentation. Part of what I want to do with this, if we were to do it, would be to try to preferentially do big writes out to the disk rather than always writing small extents to the disk. So that's kind of the other piece of this, is that we have seen some fairly bad cases where fragmentation is a really big problem. And we can, go back through and just do like a online defrag process of what's there. But I'm wondering if we can do a better job of reducing fragmentation from the beginning if we allow new small extents to be placed on the fast device rather than automatically going to the slow device.
Well, maybe that's a bit different issue. So when talking about RocksDB performance degradation, I mainly imply the issue with tombstones and.
Sorry, what was that, Igor?
I mean, so I mainly implied this RocksDB tombstone issue after bulk removal, which causes performance drop. So
There is a PR I have related to that. I don't know if you've seen it. I can link it if you're interested.
yeah, the question is how general it is, because I've seen a bunch of PRs which were claiming they improve this behavior in RocksDB, but generally we still have these issues. So
Yeah.
it might help. It might help in some specific cases, but the question how general it is. That's the point.
So there are kind of two cases that are big, right? Like tombstones in the mem table and tombstones in SSD files. And there's no really, as far as I can know, there's no really easy way to deal with tombstones in the mem tables right now. We kind of actually looked at trying to add support for that in RocksDB, and it wouldn't be nearly as easy as the other thing that they have. But I'm hoping though that that if we, no one's tested this yet, but I added support in BlueStore in this PR for the compact on deletion trigger that RocksDB provides. So that basically makes it so that when RocksDB over iteration encounters a certain number of tombstones within a sliding window, then it will trigger compaction.
Yeah, but immediate question would be how it impacts the regular operations.
Well, I mean, you probably would prefer a compaction that gets rid of tombstones if you encounter it because you're doing lots of iteration, right? Like I can't imagine that it's worse than like the way the snap trimming behavior is right now, where you like go and delete a number of keys and then you restart you do a seek to first again, and then you start iterating over again, and you iterate over all the tombstones that you just created, and you delete a couple more things, and then you start it over again and do it all over. Like that's how we work right now. It's awful. So at least if you triggered compaction, then all of those subsequent tries would now be over a fresh range, right, with no tombstones in it, and you add some more until it grows, and then eventually you trigger compaction again. But it should be way better than just doing like the full iteration over everything every time.
Okay, but okay, so you can see the PR is still tagged with work in progress. Are you planning to have any modifications?
Yeah, it's never been tested, and I added some other RocksDB settings in there, but we can pull those out if we don't want to have it all in this one PR. But we might actually have a test case for this PR now. It sounds like there's a user cluster that's facing issues with basically just having timeouts because of slow iteration and snap trimming. So maybe we can finally test it, but I wanted to bring it to your attention because might be useful.
Yeah, but maybe pack that in a bit different form. So instead of updating RocksDB settings, which I gave you, so maybe use that like an experimental feature to be enabled by additional parameter, and this would modify the RocksDB settings and things like that. So I mean, users might want to have more control over that stuff and enable or disable it at some point to play, to try.
Yeah.
Well, personally, I would be a little scary about having all these changes in production cluster by default.
Yeah, I agree. So maybe we want to break this up into two separate PRs and do the setting changes for just the like general RocksDB settings that changed in there as a separate thing, and then this other one to compact on deletion as an independent pull request.
And maybe even one more step, which is having two sets of RocksDB options and switch between them with a difference, which like, well, our default settings and experimental DB improved options.
Yeah. Those settings that are in there are from the RocksDB tuning article I made. I don't know if I ever sent that to you, but it's available. It's this thing here. The improvement is pretty significant, and we can avoid the right amplification increase by making sure that level 0 and level 1 seem to be matched properly. It was a
but again, for instance, one of the questions is, would it fit any other cluster? Well, it makes things better for your case, but I'm a bit scary about the bulky modifications for everyone.
No, I agree with you. I mean, that's why I've resisted this for a long time. Our defaults work pretty well, but
yeah. So when we modify just one parameter, it's more or less fine. But when we modify half of them, and some with pretty significant increase,
The problem is that
it's scary.
yeah, the problem is that changing one thing at a time doesn't fix it. Like it doesn't make it better; it makes it worse. Actually,
Right. But
yeah,
that's why I prefer a single switch to enable these faster changes and
yeah.
downgrade back to regular
It's not a bad idea.
settings.
Okay, we could do that though. We could add a switch for it that just uses these other settings as kind of you know, try experimental performance RocksDB settings or something. Okay. Igor, if I made those changes, could I get you to approve the PR?
Yeah, I think so.
Okay, cool.
So if that's not enabled by default, then why not? Yeah, we definitely need some waiting period for users to get used to this stuff and to verify it.
Yeah. I'm a little concerned that if we make it experimental, we will have very few people actually trying it. But we can see maybe we can get some of the more advanced users to try it on some of their clusters and just see if we can get feedback.
Well, it definitely will take some time, but well, from time to time I face this tombstone issue, and at this point I might want to try new features, to try these new options to check if it helps. Or maybe in some testing clusters. Definitely, I'm not planning to enable that in production clusters immediately.
Sure. I think
We
in
need
general
some.
the RocksDB the trimming feature for basically compact on finding too many tombstones. I don't think that is ever going to be a bad thing, frankly, if we have it set high. If we had it set low, I could see it being a problem. But if we have that set fairly high, I can't imagine that it's worse than the way things are right now. Just because right now, if you have enough tombstones, the OSD crashes with heartbeat timeout, right? Like it's hard to get much worse than that, short of data corruption.
Well, but the question is, well, when OSD crashes, it's definitely better to have that. But there might be a case when it still works fine with default settings, and more aggressive stuff causes some issues in this case, or impact something else. So I recall some cases when users took a bunch of RocksDB options from, I don't know, from unknown reasons, and then they get some issues which very hard to troubleshoot.
Yeah, absolutely. Agreed. All right. Well, I don't think I have anything else other than this stuff. Were there any other things people want to bring up before the end of the hour here? If not, maybe.
Just one small PR. for hybrid allocators, which might impact performance as well. So I faced an issue in the field when in best fit mode, the allocator might take pretty significant time to iterate over unaligned chunks. So they are still long enough for BlueFS allocation, but they are unaligned, and hence it has to bypass them. And this PR provides a bit different sorting strategy to overcome this. So please take a look.
Yeah, I saw Adam's reply, and I wanted to ask him about it because I was trying to understand what his criticism was.
That was my question as well.
Yeah, that's why I haven't commented on it yet, because I saw his reply and then that made me question if I quite understood what was going on. So maybe we need Adam to talk about it more and understand it. But generally speaking, I agree with you. I have seen cases where going into the slow mode, whatever we called it, was it best fit?
Yeah.
Yeah. When we go into the slow mode, it is quite slow and can take quite a long time. So if this works, I guess I'm all for it.
Yeah, not to mention that I'm working on 4K chunks for BlueFS, which might make this stuff useless.
Igor,
Yeah,
maybe you're.
so
Oh, yeah, go ahead.
just to mention that I recall a bunch of recent cases when BlueFS reported no space on a highly fragmented space due to long chunk or long location chunk. So definitely we might want some fix for that. And I believe 4K allocation unit be maybe we shouldn't use it by default, but we should be able to fall back to 4K allocation chunk in case of a lack of memory, a lack of space.
Igor, do you think that your PR reminded me that I still haven't done anything with this one, short of the fix that we made to make sure that we're starting at the same offset that we left at last time, rather than restarting from the beginning. That fix went in as a separate PR, but I haven't done anything with the switching to a time-based near fit algorithm instead of using bytes and distance and that kind of thing. Do you think it's still worthwhile to maybe switch to basically deciding how much time to spend in the near fit before switching to best fit? It made sense to me at the time, but what do you think?
Well, I recall we made simpler solution at that point, which is keeping the previous software.
It definitely helps. Yeah, the fix makes it much better.
So right now I can't say that I recall any issues with linear fit mode, So maybe
I guess the question would be whether or not you could end up spending a lot of time searching for space in near fit mode, even when you start off at the last search location. I mean, it should be much better, right? Because you're not just spinning over and over again in the same location. You're always moving forward now.
right. And in this respect, I actually realized that we do not have any metrics to measure. So we do not collect any statistics how we behave in the field, even trivial performance counters, So
Yeah, exactly. It's a little bit of black magic here, and it's hard, right? Because you don't want to impact the performance of the allocation algorithm by adding counters and doing things.
well, having simple performance counters wouldn't bring much overhead, I believe. So I started with this new with this patch I shared before. I introduced a couple of new performance counters for BlueFS allocations, which is average allocation time and maximum one.
Okay.
So yeah, now the question is whether we need some improvements in this or that case or not. And again, we don't have enough metrics for that, and so it's up to estimate if we need this switch to time-based algorithm or not. That's the point.
Yeah.
Because, well, artificial test cases, let's.
I guess the biggest
That might
advantage
be.
the way I see it, the biggest advantage of the time-based approach is that you have a hard limit, right? Regardless of distance or count or anything else, you know it won't take longer. Well, it might take a little longer than this, but it's essentially bounded.
Yeah, that's true. So yeah, maybe it's more time.
Yeah, I guess it's bounded by the the limit you put plus potentially the time of one search. Because you could be in a search, that you have to finish before you hit the limit, but it's close to the limit. Okay, well, Igor, I don't think I have anything else. I'm happy to comment on your PR if you want, but I think I'm hoping that Adam will maybe just reply and we can go from there.
Well, just wanted to offload some stuff from Adam.
Oh yeah, sure. I mean, I can review it too if you want and just take a look and see if it looks reasonable. I'll try to do that. All right. Anything else, anybody? Well, have a great day and talk to you later. Have a good week. Bye, everyone.
Bye.